So simply a process is the transformation of input into output. So in order to have an understanding of how the process behaves, how the process is performing, a process manager has to answer three important questions. One is, on average, how much time a flow unit spends within the process boundary? How long does it take for a flow unit to go through this process of the transformation? Sometimes this is referred to as the flow time. A very important measure. We want to know on average how long does it take for a process to be for a flow unit to be processed. Then the second question is, on average, how many flow units pass through the process per unit of time? Okay, you would want to know, any process manager would like to know is, on average, how many units go through the process. And in other words, what is our average throughput? Okay. Sometimes the throughput is referred to the flow rate. What is the flow rate of a process? On average, how many units flow through the process per unit of time? The third measure is, we want to know on average, how many flow units are within the process boundary at any time. On average, how many flow units are within the process boundary at any time? Are they floating through different stages of the process? We can refer to that as what is our work in process, and sometimes referred to as the inventory in the process. Inventory of the process. So three very important process measures. What is our average flow time? What is our average flow rate? And what is our average inventory? So, for example, going back to the let's say emergency room example, or a medical clinic. On average, how many patients are floating in the emergency room or in the medical clinic? Some are standing, some are in the waiting room, some are being examined, some are waiting in the exam room. So on average, how many flow units are floating through the process? So these are the three process measures that we're going to discuss in detail. One is the flow time. What is the average flow time that goes through the process? In our lecture, we designate the flow time as capital T. The flow time of a process is the total time spent by a flow unit within the process boundary. So it goes through different stages of the process. What is the total time that the flow unit, you recall we have a network of activities and buffers that come together in here. What is the average flow time, the total time that the flow unit spends within the process boundary? So if we're thinking about things that take place in the process, we know we have activities and we have buffers. So a flow unit may spend time in activity stage, and they may spend time in buffers, waiting to be processed. So when we're discussing the flow time, or T, consists of two types of times. In other words, it consists of two times that have to be considered. One is the activity time, plus buffer time. Activity time plus buffer time. That is the total time. So let's just assume you're a commercial loan institution. You have a number of commercial loans that are being processed. Let's say it takes a week or 2 weeks or a month to process that. What is the actual time, activity time? The actual activity time may be very small. How much time do we spend on checking the credit, checking the background, looking at the loan, reviewing the loan? And then how much time each loan actually sits in different buffers, awaiting to be processed? As you can see that in many organizations and many processes, the activity time is a very small portion of the total time. And flow units spend considerable time in the buffers, awaiting to be processed. So flow time is the total time that the flow unit spends in the process boundary, in the process environment. And flow time has two components: activity time plus buffer time. The second process measure is throughput of the process, or flow rate. And we designate the capital letter R as flow rate. The flow rate of a process is the number of flow units that flow through a specific point in the process per unit of time. Flow rate through the emergency room, or maybe flow rate through the exam room. Okay? Flow rate through the entire bank or financial institution, or flow rate through the review process or the inspection process. So, is the total number of units that flow through a specific point in the process. If we designate the inflow as R subscript I, that's the inflow, and we designate the outflow as R subscript O, let's see for a moment what takes place in the process. If the inflow through a process is less than the outflow, if there are we can process, our capacity is more than what we're receiving, there is no problem. You can process everything with no problem. If the inflow is proportional or equal to the outflow, this is referred to as a steady state, which we'll also cover in this course. Okay. Now, this is something that happens often. If the inflow is greater than outflow, in other words, if there are more flow units coming in than we have the capacity to process, then something happens. Okay? Things are held up, things are back up. That's how we have backlogs. In that situation, queues are formed. The queues are formed. So if you have the number of customers entering a process, orders entering a process, and the number of units that enter per unit of time is greater than the number of units that flow through the process per unit of time, then we have queues. If you have more calls coming into the call center than we have the ability to answer them, then we have callers on hold. That's why we have waiting rooms. The waiting rooms are designed to because the inflow is greater than the outflow. And that's where the queues are formed, the lines are formed. Lines are an example of this process when the inflow is greater than the outflow. The third process measure is what is known as inventory, and we designate the letter I for the inventory. The inventory is a reference to the total number of flow units present within the process boundary. The total number of flow units present within the process boundary. We may have several steps or activities in a process, and there may be flow units at each activity. We may have flow units in buffers waiting to be, we may have finished goods and products. We may have incoming goods and products. So when we're making a reference to the inventory, it's a reference to the number of units that are floating, that are present within the process boundary. So, so how many units are present in this process is a reference to the inventory. Oftentimes the word inventory is referred to material things and things we drop and break and drive and watch. What I would like for you to think is that inventory could be cash. Inventory could be the number of patients in the medical clinic. And inventory could be the number of loan applications awaiting to be processed. It could be raw materials. It could be customers in a supermarket. And that would be managing inventories are a very important job of the operations management. But one of the things I'd like for you to think about is that from now on, think of inventory as money tied up. And so as we have products all present in different stages of the process, you can think of those that as money tied up. So let's recap that. As a process manager, as a measure, as a method of measuring how our process is performing, there are three process measures we have to take into account or consider. One is the flow unit, T. What is the total time of flow? What is flow time, T? That is, what is the total time it takes for a flow unit to go through the process, to be transformed? What is our flow rate on average per unit of time? How many units travel through our process? And on average, how many units are present or floating in our process boundary? So the letter I and the letter R. So the flow time, flow rate, and inventory are three process measures. To be able to manage a process and optimize the process, we have to have a good understanding of these three process measures. There is a relationship among these three process measures known as the Little's Law, which we'll discuss shortly.